People tend to think of, robots of the future will be like C-3PO and R2-D2. Wrong. They will be the Jedi Knights, and they will be able to control the lighting just by thinking about it.
That's Professor Marianne Williams. You'll hear more from her a bit later. But if you've ever watched a good sci-fi film, you've no doubt seen this world filled with robots and machines able to think for themselves.
Murder's a new trick for a robot. Congratulations.
But if you look at the robots in real life today, we still have a long way to go before they start thinking and feeling for themselves. Right? We still have some time.
Korean champion Lee Si-dol emerges in defeat after losing the second battle in a row against a Google supercomputer called AlphaGo.
I'm Christopher Lawson.
And I'm Andrew Moon.
And this week on Moonshot, we're exploring artificial intelligence, and more specifically, artificial general intelligence. The idea that machines might one day be able to think like humans.
Or might rise up and take control. Yes, we have got some cheesy movie quotes, but we've also got some incredibly smart perspectives for you ahead on what you should be paying attention to and what's standing in the way of AI completely taking over. You're probably hearing more and more about artificial intelligence lately, but the concept itself is nothing new and dates back to the birth of computers. In the early 1950s, Alan Turing, the English scientist largely known as the father of computer science, published a paper proposing a test, or imitation game, in which a judge would try to determine whether contestants were either humans or machines.
This big paper you wrote, what's it called?
The imitation game.
Right, that's what it's about.
Would you like to play?
Turing's imitation game later became known as the Turing test and became an often used measure of intelligent systems. But it was John McCarthy, a researcher at Dartmouth College, who first coined the term artificial intelligence in 1955. He mentioned it while preparing a proposal for a conference to discuss the issue.
There are several people who are said to be the founding fathers of artificial intelligence, and that's the reason why no woman has come forth and claimed to be the mother of artificial intelligence.
AI became an idea that captivated researchers for decades, and McCarthy went on to become one of the most influential voices in artificial intelligence research. And the holy grail of all that research is coming up with a general intelligence system, something that's not limited to one discipline and can think and reason like a human.
You can have an AI that's really, really good at driving a car, but it's not good at any other tasks. It cannot help us with our climate challenges or with our global economics or with poverty or health issues. But a general intelligence can help us with all of those.
That was from a company called Good AI, who are actively trying to build a general intelligence system. However, despite the decades of work that has gone into developing general intelligence, much of the major progress has happened over the past 10 years. Computing power has increased dramatically, data storage is much cheaper now, and researchers have figured out how to better process the complex calculations required to help these systems operate.
In particular, hardware, parts of the computer called the GPU, which was designed to help computers render graphics, has turned out to be really critical for doing the kind of deep mathematics that are required in machine learning, to do them kind of at scale.
That's Liza Daly. She's a software engineer who's been working with the web for 2 decades and most recently decided to teach herself machine learning, one of the major subsets of AI. We'll also provide a link to an excellent post Liza wrote explaining the basics of AI. That'll be in the podcast description. But right now, it's back to her.
Most machine learning systems need tremendous numbers of examples from which to learn. data sets numbering in the millions, if not billions. And one thing that's really helped make that available is the existence of the internet. So if you want to teach a computer how to read English sentences, we suddenly have an explosion of English every single day, written in the common vernacular that computers can be trained on. And this stuff is all free. And even if we'd had the hardware and software capabilities that we do today, prior to the internet, I think researchers would have struggled to get as many examples, the infinite number of pictures that are on Instagram every day. That's all raw material for training these systems, and it's definitely accelerated the process.
But despite an awful lot of progress, we're still a long way from reaching the point of artificial general intelligence. While there's a lot that today's supercomputers can do in terms of crunching numbers, much of the current technology falls well short of being able to replicate the same complex thought patterns and ability to reason unique to human beings.
So it turns out that expert knowledge is not difficult to encode in a computer system or a robot, very, very specific task-based information, like playing chess. We've solved that problem. So the really big challenges back in the 50s and even today is how do we build a computer system or a robot that has the common sense of a young child?
That's Professor Marianne Williams. You heard her at the top of the show. She's the director of the Magic Lab at the University of Technology, Sydney.
And the Magic Lab is a research lab that focuses on disruptive innovation. And we've been working with artificial general intelligence for more than 20 years.
But despite the name, there's nothing magic about artificial intelligence. Building an AI system requires data and an awful lot of it. All of these systems need to be programmed and then trained to have any hope of replicating human thought patterns and the complexity of human life.
The difficulty is dealing with complexity, yes, uncertainty, and the real world. And this is what young children learn, very early. They bump into things, they fall over. And machine learning techniques today require that a robot fall over thousands of times before it actually learns anything valuable as to how not to fall over. So even today, we don't know enough about the way our own brain works, even young brains.
And although we don't yet know enough about the brain itself to fully replicate it, there are a few areas where current AI systems are catching up and leaping ahead of us mere mortals.
AI can already process and analyse huge amounts of data through machine learning and complex neural networks. Google's AI system AlphaGo even recently defeated the Go World Champion, and the computer vision systems that you may see in a self-driving car, they're already far exceeding the capabilities of human sight thanks to an array of more capable sensors that our bodies just don't have, like infrared. And one startup that's making use of all this new technology and the vast amounts of data available is an Australian company called Black AI, who have developed a system called Ether that can analyse people moving through a space.
It's a computer vision system to detect, track and recognise people across massive city spaces. So the way that works is we take these 3D vision sensors and we put them on the street, so either on street signs, lampposts, even on walls, and they map out an environment in 3D.
That's Keaton Okinen. He's one of the co-founders of Black, and says their system spawned out of a desire to build the types of AI systems you might have seen in Iron Man.
Jarvis, you there? At your service, sir.
Tony Stark has this personal assistant. It's an AI called Jarvis, and it's sort of like the ultimate home companion. It provides like the perfect personalized sort of interaction. It knows what you're doing and it can sort of help you with anything that you might need.
All right, what do you say? I have indeed been uploaded, sir. We're online and ready.
So we originally started off trying to build this and replicate that, and we weren't really happy with building a system that would just be your assistant on a desktop or on your operating system or phone. We wanted to sort of break out of the computer, so part of that was we needed to build a system to understand your behavior inside a physical space so that it could actually interpret that and be able to help you. And then we decided, hey, well, let's, instead of building smart homes where a system can understand your behavior in a house, let's sort of take that to the absolute extreme and stretch it across entire city spaces.
So how do you sort of see this technology being used?
So if you look at how I guess things work online, we know more about how people interact with our websites than we do about how they interact with our city spaces, which is kind of broken. So we sort of see ourselves bridging that so that we can collect information on how people move through a city from one side of the city to the other, how people interact with public services like transport, and how people interact, between themselves and with built structures generally. All that information is currently just not being collected, and it's a hugely missed opportunity for optimization generally.
Okay, so that's all well and good, but does this not feel a little bit Big Brother-esque? Gathering all this data from public places and tracking how we move in the open.
That's what I thought too. So I put that question to Keaton because I figured surely I wasn't the first and the only person to be asking that question.
So we're building a system to track and recognize people across public space and understand their behavior. The obvious, I guess, response is, hey, I don't want to be tracked, and is that even legal? Can we do this, that, and the other? So I guess our answer to that is everything at the moment. We're trying to anonymize points of data. So rather than knowing that James is walking through a city street, then we know that there's a white male who's 182 centimeters tall, walks at a certain pace, and might be Caucasian, age 22, yada yada. So we collect a lot of features that might be able to eventually identify James, but right now we're sort of just not crossing that final bridge.
Okay, so this is... It sort of has the perception of, potentially being a bit 1984 Big Brother sort of thing, which is obviously something that you're going to have to deal with. How do you see that playing out long term?
Definitely. So I think there's a couple of things to note. The first being just around how we feel about privacy as a society. So there's quite a lot of shifts that are happening, I guess, socially. You can sort of see that happening online with people giving up their privacy for convenience every day, right? When you look at Facebook, Google services, all of those are built on data so that they can collect more information about who you are, build personalized services, and you sort of get to enjoy that experience, which is great. That's definitely shifting into the physical domain, and I think it's happening more and more.
And we'll be back with more Moonshot in a moment. It turns out this question of privacy is actually a recurring theme in the discussion over artificial intelligence. And when you start discussing the idea of having a general intelligence system, it raises a bunch of other questions, mostly about morality.
We shouldn't try to stop progress in AI. Instead, we need to ensure that it's aligned with our own values. We need to understand exactly how these algorithms work so they produce the results that we want. But who's to say what good values are?
That was Suraj Raval. He was one of the speakers at the Next Web conference in Amsterdam. I recently went along to see what happens there. It's basically a huge technology conference, and it was held in this old gasworks building. Everyone with an idea or interest in tech goes there to talk about the future and what's happening in virtual reality, to self-driving cars, and of course AI. I listened to as many of the discussions around artificial intelligence as I could, and a lot of them centered around this intersection of data collection and privacy. Because all of these systems need a huge amount of data to work, and where there's data, there's a potential for that data to be misused. And the other problem is that if you don't train the system correctly using good data, there's potential for the system to think it's solving a problem, but actually create a new problem, a moral problem, where the AI system might decide that the best way to solve its task is to terminate you.
You're terminated. Hasta la vista, baby.
I think that everyone is assuming that at some point when you have enough kind of interconnected nodes that there will be some type of emergent consciousness that happens. And, we just don't know if that's going to happen. Or one thing is for sure, and that is that using these technologies in a very directed fashion to help us identify new potential cancer drugs, or there's 1,000 different use cases like that where it's just like a no-brainer, right? And I'm willing to trade privacy for an improved quality of life.
That's Kevin Rose. Kevin is currently an investor with a company called True Ventures, and he's also started a number of companies himself.
I think that anytime you have machines analyzing our data, especially our private data at scale, there are issues around it. I don't think that the machines are going to rise up anytime soon and try and take things over. It'll be really interesting to see how they perceive the world, the only reason we perceive our world the way that we do is because of the hardware that we have built into our bodies. I mean, in our senses, right? And they don't have eyes, and they don't have a thousand different sensors that we do that are very sophisticated. And so it'll be interesting to see if they can grasp, if this does happen, if they can grasp what it's like for us to live in this tangible world where they're more zeros and ones kind of digital world.
I've observed much human behavior. And the more I see, the harder it gets to find a logic to it.
Oh, you sweet girl. There is no logic to love, anger, wonder, joy.
I understand the concepts, but I don't feel them myself. And unfortunately, they've created a paradox in my programming.
And with all of this data being gathered by AI systems, there are a number of other questions being raised too. What could happen if it all got hacked? Or if the AI misinterpreted all these inputs in a non-lethal but still impactful way? And what role should governments have in keeping these AI systems under control?
This is critical for mankind because we don't want to be deploying technologies that we do not understand. It's also important for nations like Australia, to explore and to lead, because we wouldn't want to be importing this kind of technology from, another nation state. Of course, security is huge. I mean, ethics is big, but just security is enormous.
Do you think our governments are equipped to deal with this technology as, it changes the marketplaces?
Absolutely not. But I don't think it's necessarily up to government. This is really something for society and business as well. I mean, if we're waiting for the government to solve this problem, then we're really in trouble.
There's a legitimate concern that's already being borne out about these systems amplifying existing human bias. They're only as good as the data that you feed them.
That's Liza Daly again.
And they are exceptional computation machines. So they will find correlations in data that we as humans are not able to identify because there are just too many parameters, or the data is too immense. And maybe areas we haven't even thought to try to derive correlations. If it's in the data, the computer will pick it up. And what that could mean is that if you design a system to decide whether someone is a high risk for some behavior that we as humans know might be correlated with race or socioeconomic status, not caused by, but just correlated with. The computer does not understand that distinction and will sort of happily give our bias back to us by saying, most insurance policies, with good rates are given to Caucasians. That's what you should keep doing because that's the historical precedent that's represented in the data. That's a real concern, and people are certainly aware of it, but it's very difficult with these machine learning models to really understand what conclusions they have drawn. So they're difficult to audit. It's very hard for us to look at it and actually say, is this algorithm racist? We don't really know how it got to its answer.
Just like in high school maths exams, you should always show you're working in how you got to an answer.
There's so much evidence of this already happening for people of colour particularly, who say are discriminated against when they try and book Airbnb.
That's Elmo Keep. She's an Aussie writer currently based in Mexico, chasing weird and wonderful stories at the intersection of humans, technology and society.
Or Facebook having so much socioeconomic data on people that when you go and apply for a lease, if your friend group is too poor, you're going to start getting knocked back for financing, things like that. And that's where the AI that we should be worried about is actually happening. And it's happening faster than it can be legislated against because it's happening all in the private sector. It's happening in all these proprietary companies. So I feel like, okay, please be less worried about robots and be more worried about the fact that these companies are exploiting our data and they're totally unaccountable to anyone at the moment.
So you might be worried about the huge amounts of data the AI systems collect, and what happens if someone wanted to exploit that. But Professor Marianne Williams says having an increasing amount of data might also provide some form of security.
Now, if you consider the way your brain works, I mean, you cannot recreate entire experiences. You sort of have stories, right? This is why stories are so important to us. They're a summary of what actually happened. Currently in your body, a lot is going on. Think of all of the billions of cells, So it's very hard even for the human brain to keep tabs on everything that's going on. So while data and collecting lots of it is the problem, it's probably also the solution.
No matter which side of the artificial intelligence fence you sit, it seems that much of the tech world, and especially the big players like Google, are actively pursuing increasingly advanced AI systems. Google CEO Sundar Pichai recently announced that the whole company is now pivoting to be AI first.
Mobile made us reimagine every product we were working on. We had to take into account that the user interaction model had fundamentally changed with multi-touch, location, identity, payments, and so on. Similarly, in an AI-first world, we are rethinking all our products and applying machine learning and AI to solve user problems.
You've also got Amazon and IBM who are giving public access to their systems so that you too can build your own AI-driven apps. And for investors like Kevin Rose and startups like Black, that's actually a super exciting prospect.
And I think that you're going to have small pockets of really world-class entrepreneurs, computer scientists that come out of university that can potentially create new innovations in AI, in which case those companies would probably be worth backing. But for the majority of folks out there, I think that as an entrepreneur, you're best off not trying to kind of develop the AI expertise in-house, but really just go with one of the big three, and then or big four, however many it ends up being. So, am I excited about it? 100%. Is it an area I'll be investing in? 100%. It's early days and fun to track this stuff.
I'd say AI is not magic. It's something really important to sort of realize. It's just it's a tool that everybody has access to, and anybody can learn about. How machine learning algorithms function, or how the chatbots work that you interact with every day. And I think that education piece and understanding piece is going to be really important, so that we're not scared of the future that we're going to ultimately face in the next 5 years.
If you've loved this episode, make sure to tell your friends. They can subscribe to the show on Apple Podcasts, Pocket Casts, Stitcher, and SoundCloud. And don't forget to leave us a review if you have a few minutes. It does very much so help with people finding out about the show.
Our website is moonshot.audio, and you can also find us on Facebook, Twitter, and Instagram. Just search for Moonshot Pod. Our cover artwork is by Andrew Millist.
And our theme music is by Breakmaster Cylinder.
And thanks to the Walkley Foundation for their continued support. I'm Christopher Lawson.
And I'm Andrew Moon.
That's all we have today. We'll be back with you next time on Moonshot.